Welcome back to the Deep Dive. You know how much we love exploring topics that are truly shaping our world, especially when they blend the futuristic with something as foundational as education. Today, we're diving headfirst into an area that touches, well, every student, every classroom, and probably some of your own experiences as learners: artificial intelligence and mathematics education. For this particular deep dive, we've been poring over this incredibly insightful document, a really definitive synthesis of research. It's titled Artificial Intelligence and Mathematics Education Across K-12 and Higher Education, a synthesis and research agenda. Think of it as our shortcut, to truly understanding where AI stands in the world of numbers and equations, from kindergarten all the way through college. It's truly fascinating stuff.
It really is. And what's genuinely exciting here, I think, is just how quickly this field is evolving. As the paper highlights, the public release of these highly capable large language models, LLMs, back in 2022, it just triggered this massive surge of new tools. We're talking everything from advanced homework solvers, detailed step-by-step explainers, to these integrated tutoring assistants. And mathematics in particular, it's kind of a high-stakes target for AI.
Why is that exactly?
Well, mainly because it's so central to the curriculum, right? And also because many math tasks have a very structured nature, which AI tends to handle well. So our aim today is really to cut through the noise, show you what's genuinely effective, what the real risks are, and frankly, what we still need to figure out as this technology matures.
Okay, so to start, let's maybe unpack the two big players in this space, because you hear these terms thrown around. On one side, we have what's known as Intelligent Tutoring Systems, or ITS, been around a while. And then on the other, the newer, maybe buzzier large language models, the kind like you've probably heard about or even played around with yourself. What's the fundamental difference? For a learner, what sets these apart?
That's a really crucial distinction to make. So intelligent tutoring systems, ITS, they have a much longer history. We're talking decades. These are adaptive tutoring engines. They're built upon what we call domain models. You can think of that as a super detailed, structured map of all the knowledge and skills within a specific subject, like algebra or geometry.
Gotcha, like a knowledge map.
Exactly. And they also use mastery learning algorithms. Basically, these make sure students truly grasp one concept before they move on to the next. And the research, including, recent systematic reviews, it shows consistent positive effects on student learning in math when these IT systems are implemented well, like with high fidelity.
So they're the workhorses, tried and true.
Pretty much. They're the established tech designed specifically to guide students toward deep, lasting understanding.
Okay. And then came the LLMs, which, as you said, are a whole different beast. So when LLMs burst onto the scene, researchers must have immediately thought, okay, hang on, can these generative models do what ICE does? Maybe even better. What's the initial verdict been?
Yeah, that was the immediate question. And the verdict so far, it's a real mixed bag, which is actually fascinating. Some recent studies do show that LLM-generated hints and these scaffolded prompts can improve short-term practice performance and engagement, too, in things like algebra and statistics tasks.
Okay, so there's something there.
Definitely. For instance, there was one randomized online study, had over 270 learners involved. It found that hints generated by ChatGPT produced learning gains that were actually similar to other types of hints, but that was under controlled conditions. So there's a definite promise, especially in their ability to generate diverse, kind of context-rich feedback.
And I feel like there's always a but. Here it sounds like current LLM-based tutoring often struggles. It doesn't quite match the adaptivity. And you use the term pedagogical fidelity of established ICE. What exactly does pedagogical fidelity mean in this context? Like, how true is it to good teaching?
That's a really important question. Pedagogical fidelity basically refers to how closely an AI system sticks to evidence-based teaching principles, things we know work for learning. LLMs, just by their nature, they tend to provide more direct answers. They often lack the structured, evidence-based feedback loops that IES uses.
Loops that make you think.
Exactly. The ones that promote what we call productive struggle, that kind of crucial sweet spot where you're challenged just enough to actively grapple with a problem. That's what leads to deeper understanding. LLMs also often fall short on fostering metacognitive growth, which is essentially learning how you learn, understanding your own thinking processes and strategies.
Oh, okay.
So unless LLMs are heavily fine-tuned, really customized and integrated into specific teaching structures or scaffolds, They're more like a brilliant conversationalist who infers your understanding, which is powerful, don't get me wrong, but it's less precise for systematic skill building than an IT that's actually continuously tracking your exact mastery level and misconceptions.
Right, that distinction really clicks, inferring understanding versus precisely tracking it. Okay, so for you, the learner, listening right now, what does this mixed bag truly mean in terms of outcomes? Is AI consistently making a difference, or could it, maybe counterintuitively, become a distraction from genuine learning?
Well, the paper synthesizes these large studies and also news-reported trials, and honestly, they paint a truly complex picture. While some controlled experiments, some field pilots, they do report significant learning gains and higher engagement when students use AI tutors. But these are tutors specifically designed with pedagogical constraints, built-in teaching rules, basically.
Okay, so the design matters hugely.
Hugely, because other studies report neutral or even negative outcomes. And this is especially true when using the AI encourages just copying or like a superficial processing of problems rather than really digging in and understanding them. It's not just about getting the right answer, right? It's about how you get there.
Ouch, yeah, that's precisely what we want to avoid. The paper even mentions a study reported in the press and backed up by researchers that found high school students using certain generative AI tutors actually performed worse on later tests. That's pretty striking. What's the likely culprit there? Just getting the answers too easily?
That's the main suspect, yeah. Over-reliance on the AI output without the right kind of scaffolding or support. If the AI simply hands you the direct answers, it can fundamentally bypass that crucial productive struggle needed for deeper cognitive processing. You don't build the mental muscle.
Right.
This can prevent you from developing those robust mental models that lead to genuine understanding and, importantly, the ability to transfer that knowledge to new situations. It's almost like the academic version of having a calculator for every single basic math problem. Sure, you get the answer, but the foundational skill might just wither away over time.
That's a perfect analogy.
Okay.
Okay, but conversely, the paper also points to a study in Nature, a big deal journal reporting scenarios, where AI tutors actually outperformed in-class active learning. But only under specific conditions. How do we make sense of these totally opposite results?
Yeah, it seems contradictory, doesn't it? But these divergent results really underscore a critical point. It's not just about the AI itself, it's about how it's designed, how it integrates with the actual instruction, and critically, the way assessments are designed. All these factors mediate the outcomes. It's about how the AI is woven into the whole learning fabric. Like, is it a perfectly integrated ingredient or just, a splash of sauce thrown on top?
Right.
The Nature study, for instance, likely involved highly structured AI environments, ones that carefully manage the type and timing of feedback, making sure it actually promoted active thinking, not passive reception.
Okay, so context and implementation are everything. It's also clear AI's role is expanding beyond just tutoring. Now it's stepping into grading, which for many people sounds like a dream come true. Imagine getting instant feedback on your complex math homework. But how's that actually going, in the real world?
It's definitely advancing rapidly. Automated scoring and feedback tools for math, including things like multimodal scoring, which means it can accept images of handwritten work.
Wow, okay.
Yeah, it's pretty sophisticated. Studies describe models that can not only score, but also provide comments on student solutions and even their self-explanations about how they solved it. Pilot implementations, especially when teachers are involved in the co-design process from the start, show immense promise, incredible scalability and speed.
But there's a but coming, I sense.
There is. They also present significant challenges. There are inherent error modes. The AI makes mistakes. There's the crucial need for teacher trust, which is huge. And the challenge of actually aligning these tools with existing classroom workflows. It can't just be another thing dumped on teachers. So the research really stresses the need for transparent error reporting, robust teacher oversight, humans in the loop, and mechanisms for correcting systematic biases in the grading.
Right, it has to be a tool to help teachers not replace their judgment.
Exactly. Empowering teachers with a powerful assistant, not replacing their crucial pedagogical insight.
Okay, this all sounds incredibly powerful, but as we scale this up, what about fairness, equity?
Yeah.
And, speaking of practical challenges, there's that elephant in the room, academic integrity.
Yeah.
How do we stop students from just having the AI do their homework for them?
Yeah, these are massive concerns. And policy documents, empirical surveys, they all highlight significant equity and integrity risks that we simply cannot ignore. For one thing, access is uneven. Access to the more powerful, often subscription-level AI tools isn't universal.
The digital divide again.
Exactly. There's a very real concern that students who can afford or access these advanced tutoring apps might gain unfair advantages, potentially making existing gaps even wider. And at the same time, generative AI, while brilliant, can produce plausible but incorrect solutions, what people sometimes call hallucinations.
Right, I've seen those. They look right, but are subtly wrong.
Precisely. And that risks spreading misinformation to learners who might not have the background knowledge to spot the errors. Organizations like UNESCO are now recommending things like comprehensive competency frameworks for both students and teachers. Specialized training is needed. And policy updates on assessment design and academic integrity rules are crucial to mitigate these risks.
It also raises that huge question. How do we make sure this technology actually benefits all students, not just some, and crucially, without undermining the very purpose of learning itself? That sounds like a real tightrope walk.
It absolutely is a true tightrope walk.
Okay, so pulling all these threads together, for someone listening, maybe a teacher, maybe a student, maybe a parent trying to make sure AI genuinely helps in math education rather than hinders it, what are the absolute non-negotiables? What's the core how-to coming out of this synthesis?
The synthesis is actually pretty clear on what genuinely works and what doesn't. So when AI genuinely helps learning, it's typically through structured, pedagogically aligned AI systems, those hallmarks of ITAS we talked about, encoding those detailed domain models, providing incremental guiding feedback. And crucially, LLMs can also help, but primarily when they are constrained.
Constrained, how so?
Constrained to deliver scaffolded prompts, hints, diagnostic feedback, things that guide thinking rather than just spitting out the direct solution. Think of it like a seasoned coach asking guiding questions instead of just shouting the final score from the sidelines.
That makes sense. And what about this idea of a human-AI hybrid model? That sounds potentially like the best of both worlds.
It often is. The research really points to the best outcomes happening when AI augments human tutors or teachers, not replaces them. So this means AI providing suggestions for feedback, maybe drafting initial comments for the teacher to review, or offering diverse practice problem variations based on student needs. But the human interaction remains central, and these co-designed workflows where teachers are deeply involved in implementing the tools from the ground up, they're absolutely essential. That's how you build teacher trust and ensure it's actually used effectively.
Teamwork makes the dream work, even with AI.
Basically, yes. Leveraging each other's strengths, the AI speed and data processing, the human's empathy and pedagogical wisdom.
Okay, so on the flip side then, what should we be most wary of? Especially if you're a student trying to genuinely learn or a teacher trying to foster that. What are the clear risks this synthesis flags?
The risks are equally clear, unfortunately. First, just unconstrained LLM output. Off-the-shelf LLMs, if you just use them straight out of the box, often default to giving direct answers. Without careful prompting or what the paper calls pedagogical wrappers, think of those as guardrails or instructions shaping the AI's output to be educationally sound. They just fail to encourage that productive struggle we know is critical for deep conceptual learning.
So they can actually promote surface learning.
Exactly. Surface learning and copying rather than genuine comprehension. It's like being given the destination on a map but having no idea how the journey works or how to navigate yourself next time.
Got it. What else?
Second big risk. Assessment misalignment. If our tests, quizzes, homework assignments, and just general classroom practices don't adapt to the reality that AI exists, the technology can enable what's called strategic behavior, which basically means traditional homework becomes less diagnostic. It's less meaningful for understanding what a student truly knows and can do independently. If you can just get the answer from an AI, how do we, as educators, know what you know and where you actually need help?
That's a huge challenge for assessment. Okay, so for the teachers, the schools, the university instructors tuning in right now, what are the immediate practical takeaways? How can they start harnessing AI effectively without causing more headaches or worse, actually undermining learning?
Yeah, the paper outlines several key implications that are pretty actionable right now. First, fundamentally, adopt AI as an assistive technology. Think of it as a super-powered co-pilot for the teacher, not the pilot itself. For instance, instead of manually grading 30 assignments looking for patterns, maybe AI quickly flags common errors or concepts the whole class struggled with. That frees up the teacher's time to spend more focused one-on-one time with students on those specific high-value issues.
Using it to enhance feedback and save time for human connection.
Precisely. Enhancing feedback cycles, generating tailored practice problems, freeing up teacher time for those crucial human interactions. But crucially, implementations must be co-designed with teachers to align the AI feedback with real learning goals.
Okay, what's number 2?
Second, constrain LLMs pedagogically. When using large language models, it's absolutely vital to prioritize configurations that generate hints, scaffolded steps, or probing questions, not the full work solutions. And maybe even require student reflection on the AI steps, like explain why the AI suggested this. That forces engagement and deeper processing.
Make them think about the AI's thinking. Interesting. Third.
Third, update assessment design. This is a big one. It means a thoughtful shift toward more in-class assessments, more formative checks for understanding, maybe performance tasks that emphasize the process of problem solving over just the final answer. It also means having really clear AI usage transparency policies. Everyone needs to understand the rules of engagement.
No ambiguity. And finally,
Maybe the most important, invest significantly in professional development. Teachers need practical, ongoing training. They need help learning how to interpret AI outputs, how to validate the correctness of AI suggestions, and how to thoughtfully integrate these tools into their teaching without accidentally undermining their core learning goals. It's a completely new frontier, right? Everyone needs a compass and a map to navigate it effectively.
absolutely. Okay, so looking ahead, this obviously isn't a solved problem. We're really on the bleeding edge of educational innovation here. What's on the research agenda for the next, say, 3 to 5 years? What are the big questions we still desperately need to answer to make this technology truly revolutionary for learning, not just incrementally helpful?
Yeah, this is critical for making real progress, and the research agenda laid out is ambitious, as it should be. It prioritizes things like large-scale field randomized controlled trials, RCTs. We need these in diverse K-12 and college settings. We need to rigorously compare different AI approaches head-to-head and measure not just short-term practice performance, can you do the problems right now, but crucially, long-term transfer and retention. Does the learning actually stick and apply elsewhere?
Knowing what really works long-term.
Exactly. Then there are design experiments. These would systematically vary things like prompt strategies, different feedback styles, explanatory, better than Socratic, or directive,
Okay.
and different degrees of adaptivity. This is about identifying the precise secret sauce, if you will, for what truly produces durable conceptual gains and that deeper understanding we keep talking about.
Finding the most effective pedagogical moves for the AI.
Right. And crucially, the agenda calls for equity-centered evaluations. We absolutely must assess the differential effects across various student groups, socioeconomic status, linguistic background, neurodiversity. This is paramount. We have to ensure AI access models don't worsen digital divides, but ideally help bridge them. Technology should be a force for leveling the playing field, not tilting it further.
That focus on equity seems vital. What else is on the research list?
We also need much more robust automated grading research. This has to include human-in-the-loop correction systems and error auditing approaches. Why? So teachers can genuinely trust the automated scores and feedback. They need to know there's a reliable mechanism for oversight and continuous improvement. It's not about automation for automation's sake. It's about building reliable, trustworthy support systems.
Trust is key for adoption.
Absolutely. And finally, there's a big push needed for developing standards and benchmarks for AI in education. This includes things like rigorous adversarial tests, trying to trick the AI to check for hallucinations and bias, and also objectively measuring pedagogical fidelity. How well does the AI feedback really align with those evidence-based teaching principles we know work? What's truly fascinating here, and it runs through the whole research agenda, is this consistent call for rigorous, equity-centered evaluations. It's constantly pushing us to ask not just if it works, but for whom does it work, and how well does it genuinely support deep, meaningful learning for all students?
Wow. What a truly comprehensive exploration into this fascinating, definitely complex, and incredibly rapidly evolving world of AI in mathematics education. From the proven track record of intelligent tutoring systems to the really exciting yet clearly challenging potential of large language models, it's abundantly clear AI is going to fundamentally change how we learn and teach math.
No doubt about it.
And the key, as we've really hammered home today, seems to be prioritizing deep learning over just getting quick answers and designing tools that genuinely augment human connection and understanding rather than replacing them. So what does this all mean for you listening right now, whether you're a learner or an educator?
I think it means the future of math education isn't just about if we use AI, but really how we design it and integrate it thoughtfully. It's all about building systems that are pedagogically sound, that are equitable, and that truly foster deeper understanding and critical thinking skills, rather than just faster problem solving or answer getting. The biggest takeaway, maybe, is that AI is an incredibly powerful tool. But like any powerful tool, its effectiveness depends entirely on how skillfully and thoughtfully we actually wield it within the incredibly nuanced landscape of human learning. It's such a dynamic space, there's always more to learn and explore, which honestly is what makes it so exciting.
Absolutely. And we really hope this deep dive gave you some incredible nuggets of knowledge to chew on and maybe spark some new questions for you to ponder as well. If you love getting this shortcut to being well-informed on such a critical topic, please make sure to subscribe and like this deep dive. It genuinely helps us bring you more fascinating insights like these. Thanks so much for joining us on the deep dive, and we'll catch you on the next one.